Hi, welcome. Today I would like to talk about structs in C# and how you can use them. So let's get started. So basically I have created a struct. It's pretty similar to a class except it's a value. So instead of class you will put in a struct. In C# you can indicate whether the element is going to be public or not. So I have put in public in front of it. And to demonstrate, typically you would want to use structs where you know the layout of memory, and if you're receiving data from some legacy application or over the wire from some other device or something like that. So typically the more usual case in C# is when you're dealing with some other fixed memory locations and how the structure is laid out. So to do that, basically you can declare unsafe in front of it, and you also want to make sure that you are compiling your C# program with the unsafe in the build. Here you can see it says allow unsafe code, so you can do that. So let's say I have that. So it basically has a couple of fields. In front of the name I have made it a fixed length array. Typically if you are receiving something over the wire or in some protocol, you're going to have a buffer and you have to put it in a fix so that it needs a known memory location. So now what you do is you basically create a new copy of a new struct. I got that, and I'm copying into this first, and you access them as basically similar to class. Here for example I'm saying first.a is G and first.name is this and all that. So that's pretty standard. So one more thing you can do with unsafe, I have put in unsafe in front of it. You can take the address of where this first is allocated. So that so I'm taking the address and casting it to a byte star pointer, and I'm just saying the size of this is going to be size of the struct, which is demo. Then I'm trying to print the offsets of where age and name is. And the way to do that is you take the reference first.a reference and subtract the beginning, which is the address, and you get the offsets. So let's just run this program and see what it prints out. Okay, so I have it running, and you can see it prints the size is 48 bytes, and also it is indicating that the offset for A, the first field is at 0, and the age is at offset 4, and the name is at offset 8. So that's based on what you had the standard values of how the memory is laid out for a struct. So there is a thing you can use to explicitly indicate how this is going to be done. So let me just give you an example of here. So you can add essentially an annotation where you can say the layout is going to be explicit, and you can see the values it has. For example, let me just show it to you. One is the auto, which is basically how the compiler will pick it. Explicit is where you specify exactly where all the various offsets are going to be. And sequential is essentially laid out sequentially in memory. So let's just demonstrate sequential here. And the packing can have a different value as to how the alignment is done. And I've just set here 1, and we should be able to just run this program. And let me just quickly get it started. So if I just run with that, you can see the total size is 46. The offset for A is at 0, the age offset is 2, and the name offset is 6 if it was laid out sequentially. So let me just demonstrate the other option which I indicated, which is to make it explicit. So I have changed it to explicit. Packing, you can specify anything you like. Let's say just make it pack it at 16 byte boundaries alignment. So I can just put in some value. There are standard values. So now you can see the quigglies. It says something is missing here, and is basically missing is it needs a field offset attribute. So let me just copy the field offset attributes I've already set up, and it should be good just as a demo. So the way to look at it is the offset for A is going to be 0 because we're explicitly specifying it. Offset for age is going to be 4, and offset of name is going to be 16. So if I just do that and run this program, let's see what it does. And you can see the size is changed obviously because they are not packed one after another, all the fields. First one is at 0, which is what we expected. Age is at 4 and field offset is at 16. So essentially you can use this to specify the layout in memory of a structure and be able to access various fields, and it can be a very good advantage. So if you want to see this or many other videos, you can basically go to my website, Gore Associates, and you can search for let's say WCF or anything else, or maybe how fast is your website if you want to measure that. So thank you for watching this short screencast, and you have a great day.